Hey guys, Dr. Callahan here for Probability and Statistic for Semester 1 for week 3, Thursday. So go ahead and pause the video to start your warm-up log. First question is, I hope you had a wonderful week with plenty of rest. What week are we in? Where would you find today's assignment on the website or Google Doc? And have you taken the SAT or ACT this year? Second question is, do you like living in Reno as a teenager? Where would you like to live eventually? And the last question is evaluate the expression when n equals 3. So make sure you put this in the warm-up log for week 3, Thursday. All right, let's go ahead and check out the last question. Here are your answers. They are highlighted in yellow. And we will proceed forward with today's stuff. So this is the breakdown for today. It is going to be on 2.4, set some operations of Venn diagrams with 3 sets. And I know this is like our 4th day on Venn diagram. This is probably going to be our last day as well. So turn over to your guided notes on page 18. If you take a look at the bottom right corner of your guided notes, you should have the website to the Google Doc for this class. And on the Google Doc, you should also have the links to the YouTube video channel for ProbStats. We're also going to be working on Objective 10, which is on page 26. We will be grading this in class, so make sure you guys practice with that. We're going to go over 3 different questions. I have a Kahoot on this that you guys can start on your own. And your homework tonight is just basically create your own description of a Venn diagram with 3 sets, draw the Venn diagram, refer to the 3 examples we're going to go over in class. All right, so go ahead and turn to page 18. We're going to be on 2.4. This is your objective. Perform set operations with 3 sets. Use Venn diagram with 3 sets. Use Venn diagram to prove equality of sets. Okay, so taking a look at this part right here, example 1 asks you to find a intersection, because this part right here is called, intersection. And actually, I don't like that, so let's just erase it. Intersection with B union not C. All right, so looking at this right here, let's go ahead and start from the very beginning with the inside of this. So what is not C? Well, C is 2, 3, 4, 6, and 7. So not C, you will compare it with U, and that will be 1, 5, 8, and 9. So this is going to be not C. Then I'm going to take a look at B and see what is in B. Okay, so then when I do that, I'm going to look at what is the union of B, and B is right here. That is not C. So what essentially I'm doing is I'm going to be comparing B with not C. And because it's a union, you're going to include everything. So that's going to be 1, 2, 3, 5, 6, 8, 9, which is what you have right here. Okay, so now we're done with the B union not C. Let's now look for set A. Set A is going to be 1, 2, 3, 4, 5. So if you're looking for the intersection of A and B union not C, essentially it's asking you what do they both share between this set right here for A and this set right here for B union not C. So let's take a look. They share 1, so that's my answer. 2, and I should probably circle that. They also share 3. They share, oh, nope, not 4, just kidding. Got a little bit ahead of myself. And they share 5. So that will be your answer. 1, 2, 3, and 5. And that is your final answer. So you can go ahead and take this and break it into small little parts and then bring it all together at the end. Now let's take a look at this part here. It says the region shown in dark blue. If you were to look for these sections, like for example, region 5, which is this piece right here, the equation to find them will be this region represents the element that are common to set A, B, and C. So it will be A intersection B intersection C. Now the section in light blue will be in these little areas, kind of the outer circles. And for example, region 2, which is right there, is this region represents an element in both set A and B that are not in set C. So A intersection B, intersection not C. So essentially, if you want to look at the region and figure out what the equations are, this is how you would kind of look at that. So let's take a look at example 2. It says use the Venn diagram to find, and here it says A. Well, if you look at A, we're going to have to use the regions. So if you look at A right here, A would include 1, 11, 3, 2, 12, 5, Roman numeral 5, I should say, 5, 7, Roman numeral 4, and 6. So those are all the numbers that are inside A. When you're looking at A union B, you're looking at all of the numbers that is inside A and all of the numbers that's inside B. So it's going to be a pretty extensive list because it is a union. So that would be Roman numeral 1, Roman numeral 2, Roman numeral 3, Roman numeral 4, Roman numeral 5, Roman numeral 6. And then we'll go back to the traditional numbers between A and B. So that would include 1, 2, 3, 5, 6, 7, and 9. Next one is going to be B intersection C. So you are looking at what is shared between B and C, all of the numbers in B and C. So here is B and here is C. So what do they share? It's going to be right here. So you're going to have Roman numeral 5, Roman numeral 6, regular numbers 5, 7, and 9. Right here. Not C. So what numbers are not in C? Well, that's going to be pretty long. So if it's not going to be in C, that means it could be this set of numbers, this set, and this set. So Roman numerals 1, 2, and 3, traditional numbers 1, 2, 3, 10, 11, 12. Okay, next we're going to look at what is going to be in A intersection B and intersection C. Well, that's an easy one because it's what's shared between all three numbers or all three letters. And it will be Roman numeral 5, traditional number 5, and number 7. All right, go ahead and turn over to page 23. Pause the video and practice with 1, 2, 3, 4, and 5. Okay, I'm going to go ahead and go over these answers with you guys. So number 1 says list the elements inside A intersection B. So that means we're going to compare A with B to see what they share. They share Q, S, and Y. Q, S, Y. That'll be my answer. For 2, let's B union C. So here is B and here is C. That means you're going to include everything. And I'm going to try to put this in alphabetical order. So Q, S, T, let's see, Q, S, you know what, I'm just going to put Y, Z. And then V will be in between here, W, X, and this essentially would be my list. Now, if you want to put it back in alphabetical order, you can. So Q, R, S, T, U, V, W, X, Y, Z. There we go. In alphabetical order, okay? For number 3, you are looking at the element of B union U. So here is U and here is B. Union basically means you need to include everything that's in both sets. So it's going to be a pretty long, extensive list. So that will be Q, R, S, T, U, V, W, X, Y, and Z. Because these numbers are either in set U or in set B, but it's including everything. Okay? Number 4, you're looking at C union empty set. Well, the empty set is not going to affect it, so you're just going to include everything in C. So that's V, W, X, Y, Z. Number 5 asks you for A intersection, not B. So let's list the sets. So A is going to give you Q, S, U, W, Y. Not B means what is in U that is not in B. So you're looking at this part here. So let's see. They both have Q. There's an S. There's a Y. There's a Z. So these numbers or letters that I'm circling are not in B. That's in U. So not in B will be R, S, V, W, X. So now that I have these two sets, you look at this and it is an intersection, which means what do they both share? Well, let's see what they share. They share an S, they share a W, and that's it. So your answer for A intersection not B is just going to be S and W. All right, you guys, that's basically the 5 examples I wanted to go over with you guys today. So I will see you guys next time. Take care.